Okay, this is pretest 2, solutions to questions number 9 and 10. And these would be called complex fractions or compound fractions, fractions inside of fractions. And there's a couple different techniques you can use to do these and that you might have been exposed to at the Algebra 2 level. Um, what I'm going to say is we're subtracting two fractions in this numerator up here. And then in the denominator, you have a term h. Um, what we want to do is think of this sort of as a division problem. So we're going to be on our way to a invert and multiply by this fraction in the bottom, and we're going to make that a fraction in the bottom by thinking of it as being over 1. So we're thinking of it as h over 1, and we're seeing it as a division exercise. Well, in order to get that, we're going to have to combine these two fractions in the numerator. I have a denominator of a plus h and a denominator of a. So the common denominator would be a times a plus h. Right? So we get that by just looking at those two denominators and multiplying them. And certainly that will give us a common denominator. Now, in order to make the a plus h have a denominator of a times a plus h, I'm going to multiply over here top and bottom. So I'm multiplying by 1 and not changing the value of the fraction. I'm going to multiply by a. So 1 times a is giving me an a. On the right-hand side of this numerator, I have a denominator of a. I want it to be a times a plus h. So I multiply by an a plus h, like that. And again, multiplying by 1. Now, the thing you got to be cautious of is you're subtracting. So when you multiply 1 times this a plus h, it's going to be negative a minus h. All right. And now I'm going to combine that numerator, a minus a, and that's going to be minus h. I'm going to leave the denominator as a times a plus h. And now I'm taking this denominator and inverting it and multiplying. I'm tipping it upside down. I'm doing a reciprocal. I'm using copy dot flip. You may have heard of it before. Okay? It's a technique. How do you divide fractions? You don't. You invert and multiply. Right? So this fraction, the a minus a subtracted out. So I just rewrote that fraction right there. That should make sense. And then the second fraction, I inverted and it changed it from a division problem into a multiplication problem. Now, in that this is a multiplication problem all the way across the bottom here, this h will cancel with that h by a factor of 1. So we've got negative 1 as our numerator over what? A times a plus h. Leave it like that if you like. Call that your answer. Or write it as a squared plus AH downstairs if you like. A lot of students didn't have the factor of negative 1. Okay? A lot of students, that right there was the issue. They lost that factor of negative 1 somehow. Um, so you want to be cautious about that. You always want to be cautious about your sign number stuff. It can mess up a calculus problem in a hurry. Now, on number 10, I'm going to do the same technique. This time, numerator and denominator have separate fractions. So I'll work first up here. Compare the two denominators. I've got y and x. So my common denominator, pretty obviously going to be xy, yx if you prefer. To turn the left-hand side of this with denominator y into an xy, I'm going to multiply top and bottom by x. And so that's going to give me an x squared. to multiply the right-hand side to get an xy, I'm going to multiply by y times y. And so that's going to give me minus, there's a subtraction sign in there, don't lose it, y squared, right? Now, in the denominator, very similar, I'm going to use x squared, y squared as my common denominator, right? Subtracting fractions, you got to have a common denominator. And that common denominator, it can be easily obtained by using x squared, y squared. The term on the left, multiply top and bottom by y squared. The term on the right, multiply top and bottom by x squared. So if you see where this is going, we've got y squared minus x squared. Now I employ, just as I did in number 9, the copy, dot, the division operation changes to multiplication, and then I'm going to flip that denominator. So it's going to be x squared, y squared. The denominator is going to become the numerator over y squared minus x squared. Now, at this point, there could be some real differences. Some people might see this as, okay, there's a difference of squares, so let's write this out. X minus y, x plus y times x squared, y squared, and then in your denominator, xy times y minus x, y plus x. Some people might want to go that way with it, do the factorization of the difference of squares, and then go after your canceling. Remember to be careful doing your canceling. Right here, x minus y, y minus x, those are going to cancel, but not one for one. Instead, they're going to cancel 1 for minus 1. Those are, again, signed opposites. X is positive, X is negative. Y is negative, Y is positive. Those are signed opposites right there, so that's a cancel of -1, a factor of -1. This x will cancel one of those x's represented by that x squared, and likewise with the y. The y will cancel one of the y's represented by the y squared. So final answer, negative xy. Right? Negative xy, only thing left. Other people see that negative cancellation right here. They identify it right here. They see the same numbers switched around a minus sign. Same numbers switched around a minus sign. That's a cancellation of -1. And likewise, one of the x catches one of the x, one of the y's catches one of the y's. Again, final answer, negative xy. So those are questions 9 and 10 from pretest 2. If you have any other questions about these, please don't hesitate. Either write to us through the WebAssign portal or send a direct email to cumath@clarkson.edu. Thanks a lot.